In today's lesson, we're going to do box plots, which is just the build up of what we did yesterday. Basically, the Q1, Q2, Q3 that we found on using the data, we're going to put them onto a graph. That's all. So today's date is the 7th of May, and this worksheet is available on Trello. Alright, let's look at the definition first. It says a box plot is used to display the data in 25% intervals. That's because, remember how yesterday we said for a whole set of data, how much percentage is it, the whole thing? That's 100, right? And we cut it into half first. That's Q2. So there's going to be 50-50 on each side. And then on the first half, you have Q1. It cuts the 50 into halves. So that's 25% each. And then Q3 also cuts the second half into halves. So it's 25% for each section. And we also have, what's this number here at the very end? That is the minimum, the smallest amount, right? And on the other end, you have the maximum number. All right, so it says these 25% each section are determined by a 5-number summary, and this 5-number summary is minimum, Q1, Q2, Q3, and maximum. So these are the 5 numbers that we will represent on this box plot, which makes sense, right? Because if you look at the illustration that I just drew, it's got minimum, Q1, Q2, Q3, and maximum in exactly that order. That's because we already ordered the set of data into ascending, right? So small to large. That makes sense. Once you have these 5 numbers, you draw a scale first. So the scaled line is always first. And then you just put these 5 numbers onto the graph. In the middle, we call this part the box. It does look like a box, right? And these two things, we call them whiskers. So like a cat's whiskers. They do look like whiskers, right? So we most of the time call them box plots, but sometimes you will see questions saying it's a box whisker or whisker box plot. That's because it's got 2 components, the box in the middle and the whisker on the 2 sides, right? And how much percentage do you think the box occupies? How many parts does the box have? The box has 2 parts, right? 25% and 25%. So it's going to be 50%, the middle 50% of the data. And the whiskers are 25% each because they're only one section. And I think some of you might be thinking, even though like you say it's 25% each, it doesn't look like it's 25% each because the data doesn't look very symmetrical. Well, that's because it doesn't have to be symmetrical to contain the same amount of data. So you have to keep in mind, these lines, they only represent the position. So lines present the position of minimum, Q1, Q2, Q3, and maximum. They do not mean I'm cutting into exactly half. This is not a piece of cake, right? You can't just cut it right into half. That's because your data is not just going up by the same amount of increment. So you can have a data that's very varied. So for example, if you have 2, 3, and suddenly 15, 16, and then 30. Let's say I'll add another number, 48. So if I'm getting numbers for this set of data, it's a very varied set. So that means if I put these actual numbers onto the interval, they're not going to look like they're equally spaced, right? So the reason why, even though they're 25% each and they don't look symmetrical, is because the numbers are not equally spaced. They're not going up by the same increment. The only time when the graphs would look symmetrical is when the opposite case happens, right? It's only when you have numbers that go up by the same increment. So, for example, a symmetrical one would be like 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. Or you can have, say, 2, 4, 6, 8, so on and so forth. Or you can go up by 3, and cases like that, right? If the numbers are equally spaced, then your graph will be symmetrical. Most of the time, your box plots are not going to look symmetrical, but you have to keep in mind that every single section is still 25%. It doesn't matter if it looks smaller than the other parts. Definitely 25%. There's nothing that will change this fact. Okay, let's just look at one example. Example 1 for this set of data, find the following. Highest score, so this is the maximum. Lowest score, it means you need to find the minimum. And the range is maximum minus minimum, right? What is the maximum number? How do I read this box plot? I just go to the very end. This is the maximum amount. And I go down to the scale and I see it's 58. The minimum, I go to the other end, right? It's this one, and it looks like it's right in the middle, so it's 15. So maximum minus minimum is 58 minus 15, which gives you 43. So 43 is the range. Now question B asks for the median. Median is Q2. So Q2 in this case is this number here. And it looks like it's 41. Upper quartile is Q3. So it's this number. I'm just going to label it on the graph as well. So Q3 is 50 exactly. Lower quartile, so Q1. Q1 is equal to, that looks like 23 to me. So interquartile range is Q3 minus Q1, right? 50 minus 23. And that will give you 27. So that's how you read the graph. I think it's not too difficult, right? Example 2, draw a box plot for the scores this. So to draw a box plot, the first thing you need to do is find the 5-number summary. So you have minimum, minimum Q1, Q2, Q3, right? Minimum Q1, Q2, Q3, and maximum. So this set of data is already in ascending order. So minimum is 21, maximum is 27. Now what's Q2? Q2 is the middle number, 23, right? Q1 is the middle number of the first set, 22. And then Q3 is the middle number of the second set, 26. So these are the 5 numbers. Now the next thing you need to do is draw a scale. I'm gonna... So this is my scale. And your numbers don't have to start from 0. It starts from the smallest number on your summary. So it's 21. I'll just go 21 all the way up to 27. (22, 23, 24, 25). So it doesn't matter how big your intervals are, as long as you have all these numbers on the graph. So I have minimum is 21. I draw a straight line. Q1 is 22, so you draw a straight line at 22. Q2 is 23, draw a straight line there. Q3 is 26, and then the maximum number is 27, right? And then you can first draw the two whiskers, and in the middle you just create it into a box. So this is the box plot. Okay, example 3 wants you to construct a box plot for this. I want you to first take your time, maybe use 1 minute to work out minimum, Q1, Q2, Q3, and the maximum. So you can pause the video here and quickly do it yourselves. Alright, so this is my farm number summary. Once again, you draw a scale first. And see how the numbers here are quite far apart? I would just not go up by 1 anymore. I would probably go up by 5. And it doesn't matter what number you're starting with. You can start from 40, but I'll just start from 42. I'm not super bothered by not having like a nice neat number. See that it's actually working out pretty nicely. A lot of the numbers that I need are actually on my scale exactly. So 42, 57, 64 is not on a graph, right? But it's going to be between these two values. So let's say it's here. And I would definitely, on the scale, just draw an arrow here and say it's 64. Because it's not labeled very clearly on the graph. And then I connect them together. Also, I think it's probably worth noting at this stage that sometimes a box plot can also look like this. Or it could look like this. That's when you have numbers overlap. So maybe your so in this case, you have Q3 and maximum being the same number. In this case, you have Q2 and Q3 being the same number. It happens. And there are also, of course, other cases. As long as your 5 number summary is the correct one, even if your box plot doesn't look like an accurate one, so it doesn't look like a standard one, it's still correct. So don't be scared if in your homework you get to some questions like this. For example 4, I also want you to just quickly take a moment to do it yourselves. And example 5, actually. I'll just get you to do these questions yourselves first, and then maybe take 5 minutes, and then I'll reveal the answer right after. So you can pause the video here and quickly do it yourselves. I was doing it myself, and then I realized that maybe some of you would be stuck at how to find Q1 and Q3 for this question, right? So to find Q2, you just do n plus 1 over 2, and n is 32. But how do you find Q1? So Q1 is the middle number in the first half, right? So that means I guess the problem is how much is n. Now, if there are 32 numbers and you cut it into half, that means there are 16 numbers on each side, right? I'm taking the average. So for example, if I have 1, 2, 3, 4, these 4 numbers, and then I want to find a median, I cut in half like this, and I get the middle number here. So that means there are 2 numbers on each side. That's because you just cut this 4 number set into 4 divided by 2, 2 numbers each. So same case scenario here. There are 32 numbers. Cut it in half, so it's very obvious that there are 16 numbers on each side. So n is equal to 16 when you do Q1 and Q3. So it's going to be 16 plus 1 over 2, and that will give you 8.5. So that means you're taking the average of the 8th and the 9th numbers. So 8th and the 9th numbers are 2 and 3, because 2 is the 8th number and 3 is the 9th number. So the average is 2 plus 3 over 2. 2.5 is the number you're looking for. So Q1 is 2.5. Now for Q3, if we are just given a set of data, then we can just say, oh, the middle number in the second half is the Q3. But then if we're just doing a cumulative frequency table, that means we're getting the middle number in the second half. But how many numbers are in the first half already? Because we need to use the cumulative frequency to find this number, right? We'll do the same thing, n plus 1 over 2 first. And n is equal to 16, because there are 16 numbers in the second half as well. And this will also give you 8.5. So that means it's the 8th or the 9th number in the second half. But that's on the basis of you've already gone through the first half, right? So the actual position of it is 16, because there are 16 numbers in the first half, plus 8.5. So it's going to be the 24.5th number, which is the average of the 24th and the 25th numbers. So the 24th and the 25th numbers are both 6. That means Q3 is equal to 6. So if you didn't understand this part, maybe you can replay the video and just rewatch it again. But yeah, with Q3, if you're given a cumulative frequency table, then what you need to do is add the first half's amount to it so that you know exactly where in a total set these 2 numbers are. And then I guess drawing the box plot is not the most difficult thing in the world, right? So starting from 0, let's just go up by 1. Alright, so 0, 2.5, 5, 6, and 9. So connect them. This is your box plot. Alright, example 5, you're given this frequency table. The scores are from 110 to 115. So minimum and maximum you can already determine very quickly. They're 110 and 115. Alright, so you're given a frequency, but to be able to find the median Q1, Q3, we need to find the cumulative frequency for this data. So you need to add another column, and then you have 5 plus 22 is 27, 27 plus 26 is 52, 52 plus 25 is 77, 77 plus 17 is 94, and then 94 plus 5 is 99. Let me just quickly check if the numbers are correct. Yep, so I think maybe you can try to use the method that I taught you just then, refer to example 4, and you can see if you're able to find Q1, Q3 yourselves. You can pause the video here and try it. Alright, so I got that Q1 is 111, Q2 is 112, Q3 is 113. So I'll just quickly explain why there are 49 numbers on each side. So why I used n equals 49 for Q1 and Q3. That's because this is an odd set, right? There are 99 numbers. So if I find that the median is in the middle, so let's say there's one number here, there's going to be an equal amount of number on each side, right? So I've already determined that in the 99 numbers, the one number is the median. So there are 98 numbers that I can cut into halves. So divided by 2, that's 49. So there's going to be 49 numbers on each side, plus the median, plus another 49 numbers on the other side. That's 99 numbers in total, right? Yeah, so I guess the difference between an even set and an odd set is that with the even set, you cut it right into half. It's easy. But then with the even set, you have to take out, so if I have 1, 2, 3, 4, 5 numbers, you actually take out the the median, and then you see how many numbers are on each side, right? So I'm applying the same principle here. Now drawing is once again quite simple. So 110, 111, 112, 113, 114, and 115. So you do 110, 111, 12, 13, and 15. So join them together. That's your box plot. Alright, so that's today's lesson. If you have any questions at all, please just jump on Zoom to ask me. Thank you.